In this section, I'm going to talk about rectilinear motion with constant acceleration. This is under the rectilinear motion. During freefall, a parachutist reaches terminal velocity when her weight equals the drag force. If motion is in a straight line, this is uniform rectilinear motion. For particles in uniform rectilinear motion, the acceleration is zero and the velocity is constant. When derivative of the position with respect to the time is constant, it means the particle has a uniform rectilinear motion. When integrated from dx and v dt, we find the equation of motion for uniform rectilinear motion. Careful, these only apply to uniform rectilinear motion. If forces applied to a body are constant and in a constant direction, then you have uniformly accelerated rectilinear motion. Another example is free fall when drag is negligible. For particles in uniform accelerated rectilinear motion, the acceleration of the particle is constant. You may recognize this constant acceleration equation from your physics course. A equal dv over dt. We can rearrange to dv equal a dt. That is, the a is a constant. Now we integrate both sides. Again, choose proper the integration limit on the both sides. In the left side, the low limit integration from the initial velocity v0, and for the right side, we integrate from time 0. After integration, we got v minus v0 equal a times t. Then we can rewrite as v equal v0 plus at. From this formula, we can find the velocity at any time when the a is constant. In this formula, v and t is variable and a and v0 is constant. Now for position, we use the kinetic formula, and from the previous step, we found the v, and we substitute in v and integrated from both sides. For the left side, the low limit of integration from S0, and for right side, we integrate from time 0. Again, in the equation, X and T variable and the other is constant. In the last kinematic equation, ADS equal VdV. We substitute A constant to A and we integrated both sides. After rearrangement, we got this formula and this equation for the velocity as a function of position. And as you can see, there is no any time in this formula. Just careful. This equation used when the acceleration is constant. Example. Bike starts from rest and travel at a constant acceleration of 3 meters per second square along a straight path. How long does it take for it to reach a distance of 100 meters? Okay. And for the second part, what is its velocity at that point? From the equation, we know that we have A 3 meters per second square, and at time t0, v0 is 0 and s0 is 0. From this formula, write the equation of motion for constant acceleration, and when we substitute, we got this equation. For 100 meters, we find the time 8.17 seconds. Okay, And for finding the velocity at that point, we substitute this time to this equation and we find the velocity 24.51 meter per second. Next example. Engineering testing a vehicle that will be dropped by parachute estimate that the vertical velocity of the vehicle when it reaches the ground will be 6 meters per second. If they drop if they drop the vehicle from the test rig shown, from what height should they drop it to match the impact velocity of the parachute drop? If the only significant force acting on an object near the Earth's surface is its weight, the acceleration of the body is approximately constant and equal the acceleration due to the gravity at sea level. Therefore, we can assume that the vehicle's acceleration during its shortfall is g equal 9.81 meter per second squared. The coordinate S measure the position of the bottom of the platform relative to its initial position. So we know that at time 0, velocity and position is 0. At V1 is meaning when hit to the ground, the velocity is 6 meters per second. We have to find T1 and S1. From this equation, we find the position as a constant acceleration. And for the velocity, we got this one. So for when the V is 6 meters per second, we find the T is mean the T1, 0.612 seconds. Now we have to find the height. At time 0.612 seconds, the height is 1.83 meters. Okay. A ball was thrown straight up in the air from 1.2 meters above the ground. After 3 seconds, the ball returned to the ground. Determine the maximum height it reached. Okay, in this equation, ball was thrown straight up in air from 1.2 meters above the ground. At time 0, the position is S0 and the velocity is 0. This is the statement 0. And when reached to the maximum height, that happened in time 1, velocity 1 and position 1. This is the state 1. And later return to the ground. Okay. And this is say the state 2. And we set origin as on the ground. So we can say the initial position S0 equal 1.2 meters. And the maximum height of the height is S1, is meaning this point. Let's look at what we know and what we don't know. Here I wrote everything. At time 0, we know that the S0, but we don't know the V0. At T1 is meaning the state 1. We know that we don't know the T and S, but we know that the V is 0 because we reached to the maximum height. And time T2, 3 seconds, with S2 equals 0, but again, we don't know the V. In this equation, okay, in this equation, the resistivity of air negligible and the ball only subject to the gravity. Therefore, the gravity as a constant acceleration and the gravity as a negative value. There are different approaches, but this is ideal. First of all, we have to find V0. Okay, according to the problem, after 3 seconds, the ball returns to the ground. So at time t2 equal 3 seconds, the position S2 is 0. I wrote here. When we substitute them in the equation, to this equation, we find the V0. On the other hand, we know that the maximum height is reached when the velocity is 0. It means this is the maximum height, the velocity is 0. So we use this equation which relates the velocity to the position, and we find the maximum height, it means the S1, is 11.6 meters. Thank you.